HDD stands for horizontal directional drilling, a method that is used to introduce pipe strings underground into a horizontal drill hole. This method is especially useful for laying pipelines under the rivers. NACAP Nederland played a major role in developing the HDD technology and is now one of the world's leading companies when it comes to using this method. The equipment that was used in Sumatra didn't have to be shipped from far away, since it had been stationed in Malaysia prior to this project.
Until recently, it was a spectacular occasion to see pipe strings slowly crawl into the ground and disappear, almost as if by magic, and then to reappear on the other bank. And ministers, economic leaders and reporters came to witness the event. Today we perform for a different audience.
Okay? Yeah. That's it. Good job, mate. It's out.
All of the major rivers in central Sumatra, such as the Siak, Kampar, Nilo, Indragiri, Batanghari and Lalang, were crossed using horizontal drilling. A total of 9.5 kilometers of pipeline was put underground this way. In view of future extensions to the PGN gas distribution network, 2 parallel crossings were made under the Batanghari and Lalang. The HDD method proved to be so advantageous that it was also used to tunnel under some smaller rivers and paddy fields. The NACAP drilling team worked in Sumatra for 8 months and accomplished a total of 20 horizontal drill holes.
Okay, mate. So, where are all the minerals in
In addition to watercourses, the pipeline also had to cross numerous roads without obstructing the traffic. Here, as in other locations, the ground conditions were such that the efficient thrust boring method could be used. A Sunday without rain.
The men who worked in the swamp sections were not to be envied, working in the permanent humid heat and always being bothered by mosquitoes. The medical supplies and the medical care of the workers were reorganized after the first people became unable to work as a result of tropical illnesses. The swamp areas were spread over the entire length of the pipeline and accounted for about 80 kilometers in all. The only way we could work in these sections was to use the push and pull method. In this method, the pipes are welded together, X-rayed, and insulated on dry land at the edge of the swamp area. Mounted on rollers, they are then gradually pushed or pulled into the trench. The pipe string is very maneuverable as long as it remains floating on the water. Later, it is weighted down with concrete riders to prevent it floating back to the surface.
Concrete-coated pipes were used in other sections. After they had been welded, the pipes were supported by floats so that they didn't sink during the push and pull process. These floats were removed later. The longest section that was laid using the push and pull method was 5 kilometers long. The pipeline runs at right angles to the erosion that comes out of the mountains in western Sumatra and is crossed 300 times by small rivers. This meant that MPCC had to build lots of siphons. Building a siphon means that you have to dig a clean trench of uniform depth in the riverbed. No easy task if the riverbed is gravelly. The advantages of tunneling under all of the big rivers with horizontal drilling becomes obvious when you see how much effort involved in building just a small concrete-coated siphon. 16 months after construction had started, the pipelaying work had reached a stage where the sectionalizing block valves could be installed. These valves divide the gas pipeline into 25 sections, each of which can be controlled individually. MPCC was also responsible for the pre-production of the block valves. They were designed in such a way that they could all be made at one central location. A provisional workshop was built at the base camp in Talangduku for this purpose.
From the very beginning, the project included a whole package of measures for quality assurance and quality control. Now, at the end of the project, more experts have arrived from Europe to provide the final proof of the pipeline's quality. They sent pigs through all sections of the pipeline, one of them being a so-called intelligent measuring pig. This high-tech instrument doesn't just check the geometry of the pipes, but it can also localize any deviations there might be with an accuracy of 10 centimeters. The hydrostatic testing program was performed independently.
The pipeline was filled with river water in sections of up to 100 kilometers in length. This process took several days to complete. The actual pressure tests were performed on smaller sections that averaged 25 kilometers. The tests were conducted by a team of specialists that had come with its equipment from Germany. The pressure in the sealed-off sections was gradually increased to 110 bar. The operating pressure of the pipeline will be 73 bar.
In June 1998, we heaved a sigh of relief. In spite of all the difficulties we encountered, the final spurt had paid off, and we knew that the pipeline could go online by the 21st of August and be handed over to the customer on time. We were now able to concentrate our inspection flights on just a few targets.
One of these targets is the gas delivery and measuring station at the end of the pipeline near Duri. In addition to this plant, MPCC planned and built 2 other control and maintenance stations. These are Gezik station at the start of the pipeline and Sekanan station near Jambi. The plans for this station took into account a planned branch pipeline to supply gas to a power station in Singapore.
In just a few months, the tropical vegetation will have taken over the route of the pipeline again, and the scar left behind will heal very quickly. In spite of all the difficulties, our mission was a success. This pipeline opens up a new and significant source of foreign income for Indonesia, an important step forward in these difficult economic times.